My name is Tom McCooch. I am the VP of pre-sales for Mesh IQ. Mesh IQ, as you may know, provides management, observability, and tracking of IBM MQ, among other platforms. And we have a long relationship with IBM MQ, so we're very excited to have Kim Clark, product manager of IBM MQ, on the call today. Just by means of introduction, in my role, I've worked mainframe. I've worked distributed with primarily J2EE, very deep around that, and in open source technologies as well. Most recently, joining Mesh IQ. Previous to that, worked at many companies, including Cloudera and Hortonworks in the big data space. All right, so Kim, love to have you here. Please introduce yourself.
Sure, thank you, and thank you for having me on the call. So I'm from the UK, from a little place called Hursley, which is where we build a lot of the integration products, and especially it's the home of MQ. Although there are other locations around the world where we build it. I'm a product manager in that space. I've been working for IBM for a good 20 years, not more. It's going well over that now, and in the integration space for even longer. So yeah, I've been across the integration portfolio for quite a while. Usually speaking to customers about modernizing integration infrastructures, and we're taking the MQ focus on that today. So yeah, looking forward to it.
Yes, many of our customers have brought in the new technologies that we'll be speaking about today into their portfolios, and have been asking us questions about them. So very excited to hear what you have to say. Last but not least is my boss, Navdeep Sidhu. He is the CEO of Mesh IQ. I'll let him introduce himself.
Hi, thank you, Tom, and thanks for the introduction as well. My name is Navdeep Sidhu, and as Tom mentioned, I'm the CEO of Mesh IQ. I have been in the integration space for more than 2 decades, and I've been part of Sterling Commerce and Web Methods, and they're both part of IBM family now. And IBM has a pretty broad suite of integration products, and we are very fortunate to be an IBM partner. And the focus of the conversation is MQ, which is breaking new grounds in innovation. And we have a very exciting lineup today with Kim from the IBM MQ product organization. So I wouldn't take any further. And over to you, Kim. Let's talk about MQ.
All right, I'll start us off. So the topic today is ensuring resilient deployment of IBM MQ in hybrid cloud by choosing the right HA and DR options. First, before we get into what IBM MQ can do in this area and new releases, that type of thing, I want to start with what's the distinction between high availability and disaster recovery from an IBM perspective.
Yeah, that's a great point, and I think it's always interesting to have that discussion up front with people who are implementing this, because if you don't separate the two, then you end up with trying to create an architecture that's catering for both, but it's not sure which parts and which components are doing which. And it's still important, I think, to sort of step back and say, well, is this providing high availability or disaster recovery? So I've got a slide that kind of describes this. Let's just put this one up, and I'll dip in and out of slides as we go through, and just see which ones are useful. So these are a couple of phrases that I use to really distinguish. I think single failures on a day-to-day basis that occur from hardware and things like that. That's where you're trying to overcome that from an availability point of view. You're trying to make sure that those little interruptions don't get in the way, and that you've always got some way of keeping continuous availability going. Whereas disaster really does mean disaster. It means something that's multiple component failures that could even spread out as far as an entire region going down. And this isn't We've seen outages recently from whole cloud providers and things. That's the territory of a full disaster, where you're trying to look for how do we pick up the pieces from something where so many things went wrong. There's something that's not necessarily pulled out here, though, and that's also in this idea of how far apart are the different parts of the solution as well, and what effect does that have on all of this?
Totally agree. So I think, generally, I see multi-site as the focus on disaster recovery. So that I think fits with what you're talking about. High availability is generally with one site. Disaster recovery is across.
There's subtleties in that today, though, aren't they? That's interesting,
Yeah.
because you
What's
often
a
get
site?
these multiple availability zones now, and
Right.
availability zone is kind of a site too, isn't it? So
Kind of.
you can have yourself spread across availability zones. You're multi-site, and you're actually still in availability now. Whereas you go
Right.
back just a short time, that would have been classed as disaster recovery. So
Yeah, it definitely blurs the lines.
yeah.
So in general, what are the that's a great topic, right? So, it blurs the lines between, sort of wide area network and, local area network, just to be simple about it. But what are the expectations that are being placed on, messaging right now related to RTO and RPO?
Got you. Yeah. So RPO, particularly with a product that's handling persistence as well. So the recovery point objective is
Right.
sort of saying, well, where does that
It's not a
sit? Now,
database, but I think you have to account for that capability underneath the covers in RTO, RPO.
you have to think of it in the same way. That's right.
Yeah.
So let's just jump to here we go. Now this is my little diagram from various different ways of looking at what RPO and RTO really stand for. So I think from an RTO perspective, with a recovery time perspective, you are really, with high availability, trying to minimize that. You're never going to make it completely zero, but you're trying to make it as low as you possibly can, so that you feel almost no effect from the downtime at all with the availability side, the high availability side. Whereas when it comes to a disaster recovery, that's actually different, and it's different for good reasons. It's because of the fact that you have to make sure that you're not handling a split brain scenario where you've got two different areas that are running off in their own directions and at the same time. You almost always need some kind of manual intervention there. So the recovery time objective is usually not actually down to the product itself. It's often down to the procedures and the processes wrapped around that make sure that this product and all the other things that went down in the disaster are safe, and we're ready to get going again on the other side. The recovery point objective then, high availability, and as I say, that could mean multiple sites nowadays. That could be availability zones across a region. You can target a recovery point objective of 0 so long as you've got low latency between them. And so that's the key here, whether we can get down to that level of really low latency between them and synchronously updating things. And then, obviously the recovery point objective of disaster recovery, we would love it to be 0, but some physics gets in the way, right? And so the likelihood is that we're going to have to think about that, but we're always trying to minimize it. We're trying to replicate as fast as we possibly can. So that's, high level expectations without thinking about it from a specifically a message focus or anything else, but just generally what we look at for RPO and RTO.
Thank you. This topic is very interesting to me, so I'd love to jump into it. The product team at IBM MQ talks about, the differences, or the ability to distinguish, between service availability around, the platform itself, as well as message availability, and even application availability, since obviously messaging is kind of part of distributed applications today. So very interested in those different terms and how they impact sort of the way that we want to think about HA and DR.
And the message availability is unique, if you like, to messaging, isn't it? So we have this idea of, so we start with application availability. We always try and reinforce that it doesn't matter how good MQ is. If your application hasn't got the high availability to match it, then what's the point, right? So you've got to have the applications available. They've got to have multiple instances if you're trying to get that really high availability, and they've got to be able to cope with whatever mechanisms they need to be able to stay available. But they're not, when you come into sort of our product, if you like, then you can say there's two questions. First of all, can I always access a messaging server in order to be able to put messages and to receive at least some of the messages? I can keep flowing, I can keep working. That's service availability. And that's sort of the easy one to think about, if you like. I've got access to a messaging server, and I can perform work. And then the second question is then, well, can I get to every single message? Are there, have I got, I might be able to put messages, but can I get to the messages? And can I get to all the messages? And so I might be able to get to only a portion of the messages. I might be able to get to none of the messages. That's the level of messaging availability that we've got. And those sort of subtleties are what we come down to when we're choosing between different styles of HA and also the level of complexity we go into in providing.
Yeah, agreed. So basic availability, what you're saying is being able to sort of publish the next message, right? If I'm the application, I need to be able to publish my message. I need to put it to the queue. And then next above that is can I get messages that instruct my application on what's next, and then finally can I get all of them, right? So yeah, I definitely see that. I wonder, I would imagine that you want to build those kind of smarts in your application, so that you're able to kind of react to different service levels as they change potentially.
Yeah, that's and this one of the common patterns in messaging is this idea of the competing consumer pattern, where you have lots of consumers on a queue or on a set of replicas of queues and things, and being able to spread those out, so you can sort of say, right, I've got multiple applications, got multiple copies of that queue. It might be that the messages are distributed across those queues, sharded across them, and how do I keep all that moving? And what happens if I lose one application? Well, if there's one queue manager, how does that affect my overall message availability? And of course, I mean, this is what we'll come on to when we discuss the detail, but somehow we have to make sure that we have replicas of those in all the places we need them, and across a region that can be synchronous across within a region, sorry, that can be synchronous across regions. It may not be possible. That's where the physics comes in. We have to think about other types of communication.
So Tom, allow me to chime in here. This is super exciting. So one question for you, Kim, is as you talk to a lot of customers and they are refactoring a lot of applications, so how many times do you see that messaging modernization is top of mind for them, or do you think it's more of an afterthought?
Well, it's interesting. I can dial back to one customer I was speaking to before sort of everybody had really started properly moving to the cloud, and they were setting their sights quite high. We're going to get into the cloud in the next few years, and they came to us and said, well, could we talk about messaging modernization and what that looks like? What does it look like to put MQ into the cloud? And that actually became a really short discussion, because we were already supporting containers by that time, and we already supported them in various different cloud environments. And the conversation kind of turned around to, actually, maybe it's MQ is going to help us get the applications into the cloud, because we can easily put MQ in the cloud, and we can stretch MQ across clusters to create a messaging network that goes into the cloud as well. When we put those applications into the cloud, we want them to be able to see the same sets of messages and things. And because of that natural messaging network and the dynamic rerouting that it does, then they had a lot less work to do because MQ was going to do that rerouting for them. So in a way, the moving MQ into the cloud isn't particularly hard, you know, in many senses, other than the skill sets that you have to pick up. But then it will actually potentially help you get the applications there.
That makes sense. Thank you, Kim. Over to you, Tom.
Yeah, no, I'm a big fan of messaging technology and sort of the flexibility that it enables for applications. As much background as I have in shared data, messaging is, you know, equally important from the point of view of distributed applications. So, and especially, you know, distributed across both on-prem and in the cloud. All right, so let's talk about the different options in IBM MQ today. You know, for HA and DR, there are several.
Yes, indeed, and well, yeah, it's a 30-plus-year-old product. Some of the reason for having a lot of different options is because over the years we've had to support all sorts of different things. I think that's one of our great strengths in many ways, is that we have platform native and platform optimized styles for all these different things. And in fact, there's one not mentioned on this set of options here, which is shared queues on the mainframe platform. But that's a good example of one that's come through historically from us originally, having MQ on the mainframe. These mechanisms are of various different styles. But what we've been doing is gradually improving on those styles and in terms of the types of dependencies that are required. So we want to effectively take things out of customers' hands. We don't want customers to have to manage their own high availability. So we don't want you to have to build your own high availability round MQ. We started off with adding multi-instance queue managers, which is where we said, well, okay, let's make use of this new as it was then, shared storage to be able to provide two instances of a queue manager looking at the same data. And so the storage layer was doing the replication for us. So great, we can hand it over to the storage to let that do it for us. And it's a pretty neat solution, and it's still in use in many, many customers today. It suits the purposes in many cases. The subtleties there are shared storage is potentially complex, potentially a little bit expensive. And you do have to have a particular type of shared storage to make multi-instance work. There are some locking mechanisms that we rely upon so that one queue manager can tell when the other queue manager is still using the shared storage, so it knows when or when not to switch over. That are a little bit tricky. So that dependency on shared storage was something that some customers wanted to get away from. And we started looking at what cloud native architectures were starting to look like. And this idea of sort of shared nothing architecture, could we have separate queues, separate queue managers with independent data disks? So they could just use local block storage, they didn't have to use shared queues and so on. And the easiest way we found to do that next was to look at replicated data queue managers. Now that's our term. The capability under the covers is DRBD, which is something that is a particular thing that's inserted into the Linux operating system to provide replication at the storage layer, at the file system layer, if you like. So you're not requiring a separate shared storage capability. It's being done by the Linux operating system on your behalf. So that takes you away from shared storage. It still means that you've got this dependency, but it's a dependency that we're more in control of. And we ship that particular capability, DRBD, and also a pacemaker, which helps make sure that you're always connected to the active queue manager with the product. So it's part of what we ship with the product. So that's great. That got us to this idea of a shared nothing architecture around the disks. It started to separate us from that shared storage dependency, but it kind of still has a dependency as well on this DRBD and the pacemaker capabilities that are in there underneath. And we thought, well, we know what that stuff is doing. Can't we build that into MQ itself? And so that's where Native HA came in, and this is going back just a few years now. Native HA completely sucks all of that replication capability into MQ software itself. MQ is deciding how to replicate. MQ is deciding when to switch from the active queue manager to a standby one, and so on. And so it took us into that zone of being able to completely remove all of the dependencies. And that's the flavor of the month right now is native HA. So we have several different flavors. They do still work for customers in many scenarios, and you've got many very happy customers on multi-instance that continue to use that. But there are benefits as you sort of start moving, in this case on the slide, towards the right hand to the left hand side.
Okay, so that light bulb just went off in my head when you talk about native HA. It's native to MQ,
Yes,
not native to the operating system that you're on.
that's right. It's native to it, and we also like to think of it as cloud native as well. And that
Yes.
doesn't mean just that it runs in containers, although it does, but also that it's a cloud style. That sort of terminology around cloud native in style.
That's interesting. Could you tell us a little bit more about NHA? I'd like to deep dive in a little bit there, if possible.
Sure. So let's have a look at that a little bit closer. So as with this and RDQM, it needs at least 3. So and the reason for that is we want a quorum, so we can spot split brain scenarios.
Mm-hmm.
That means that these ideally would be separated out onto separate physical nodes. They could, as we discussed towards the beginning, be separated to different availability zones in a region. And so you could have them as far apart as that, so long as the latency between them is low. So to put a number on it, we're certainly sub 10 milliseconds and ideally much less than that. So we've got to have some pretty thick pipe between things in this scenario, because they are replicating all of the data that's landing onto the queues in that active queue manager is being replicated across to the other 2 queue managers before it responds back to you. So this is synchronous replication. You put a message on, or you get a message from it, and the changes you're making are being replicated to both queue managers. Now, the way that we're doing that here is subtly different. So RDQM is also doing that, but they each do it in different ways. So native HA is just sending the logs. And the simplest way to think about what the logs are is really the changes. What are the deltas?
Mm-hmm.
What have I changed? I've read something, I've deleted something, or whatever. And that's the only thing that it's sending across. So it's the minimal amount of data it could possibly send. And very conveniently, this is pretty much the way that MQ was built right back in the dark ages when we first created it. We created it with a transaction log, just like a database often has. And then it builds the current state of the queue off the back of that transaction log. So what we're essentially doing is replicating that transaction log across. RDQM is different. It replicates the log, but it also replicates the queue data, the current state of the queue data, which means you're sending twice as much data across the wire. And that's because it's replicating at the file system level, and it doesn't know anything about MQ. So it's not, again, like you said earlier, it's not native. It doesn't know MQ, it has to just copy everything.
Yeah.
Native HA knows exactly what to replicate across the set.
That is very interesting. Can you talk a little bit about cross-region replication and how that is different?
Sure. So the cross-region replication then is asynchronous, and I haven't labeled it on the diagram, but I'll just point out. So this is where you have another queue manager. Let's say I'm calling it another queue manager, but it's the same queue manager name, right? So if it's queue manager number 1, it's still queue manager number 1 in the other region. And your active queue manager that all your clients are talking to is, say, in region 1. That's replicating to its 2 standbys in its own region, and it's doing those synchronously. But then it's also asynchronously replicating across to another region. And now we're back to the laws of physics again. It cannot be replicating synchronously because it would slow you down. As a consumer, it would slow you down from being able to get and put messages at the right speed. So to do another region, which is going to be maybe up as high as 100 milliseconds away, but certainly above 10, then that's going to be 300, 600 miles away. you've got to do asynchronous replication and put it in the background so that it doesn't affect the consumers. Now, as I mentioned towards the beginning, the recovery point objective on the left-hand side in region 1 is 0. If we fail over to one of those standbys, we don't lose a thing. It's synchronous replication, we've got it all there. If you fail over to another region, then there is that possibility that we haven't completely replicated to region 2. Now, it's really fast. It's really fast. It's sending the minimum data it can, but there is the possibility of losing something, and you can't avoid that. That's just the standard scenario with a DR across replication across regions.
So would you recommend building the smarts in your application to know the difference there, or are there other ways to know if data has been lost or dropped?
So I think what we usually say is, what does a disaster of this nature really look like? Well, it probably doesn't involve just MQ. So there's a bigger data design around this.
Yes.
That's saying, well, okay, in that circumstance, what is the business imperative? What's, what if I lose a few messages? How, I've actually had an application go down that was also replicating its database asynchronously,
Exactly.
and that's been lost as well. So
Right.
what does going back to a point in time even mean? And then you start to sort of pick up the pieces from there and say, and the likelihood is that MQ will probably be ahead of most of the other systems because it's replicating a lot less data. So in terms of recovery point objective. So essentially the main thing is then that switchover has to be manual, because you're not just aligning MQ, you're aligning MQ with all of those other applications and perhaps reconciliation processes to try and understand what's been lost and so on. So yeah, much bigger deal than just what's going on in your messaging at that point. And if you think, what's got to go wrong for you to actually need this DR nowadays? Well, you've got to have had, 2 sites go down. Two
Right.
sites in a region have got to go down. That's it's a big deal. Right?
Yes, a big deal. So NHA and cross-region replication were both announced or part of an announcement earlier this month. Is there anything additional you'd like to talk about with respect to that announcement?
Indeed, yes. So we originally brought this in so one of the things that RDQM couldn't do was running containers. Because in containers, you don't have control over the Linux operating system you're sitting on, or at least you certainly shouldn't. The whole idea is that you're agnostic to it. And so you can't be sure that those libraries required by RDQM are there. So that was one of our main motivations for creating the native HA capability. And so we brought it to containers first. We brought it to OpenShift in containers first, in fact. And then we made it sure it was available across other container environments. I'll talk a bit more about that in a moment. But the big change that we announced recently was that this technology has been sufficiently popular that we've brought it to virtual machines running Linux. We're specific to Linux at the moment, but virtual machines and bare metal that are running Linux on all the different platforms. So that could be, right across the board over to Z, even if you're running Linux on Z. So that's a really nice thing, that you can have this capability that runs in a cloud native style, but you don't have to be using containers to do it. And there are quite a few customers that were sort of saying, well, I'd love to move to native HA, but I'm just not ready to do containers yet. Kubernetes is a foreign language to me. I need to know about all these pods and service accounts and roles and this and that and the other. That's too much right now. I'll take that on in a while, but can I just have native HA? And so that's what we brought to the table in the recent release. And the other thing perhaps to add to that is we're also doing a preview at the moment around, so when you're running in containers on OpenShift, you can use a thing called an operator to make your life easier. And that does things like help you to set up all the Kubernetes pieces based on a descriptor file. So you don't really have to know that much about Kubernetes. You just essentially hand this descriptor file, which could be only a few lines long, to the capability, and it will work out how to deploy that onto your system for you. Now, that's that's great, but we only made that available on OpenShift initially. We've just made that available as a preview on EKS, so that's Amazon's managed Kubernetes, and that will be coming to full production in due course. And then we'll start looking at other areas where we can bring that operator to it as well. It does make life a lot easier because Kubernetes, as I say, is a learning curve, and maybe in 10 years' time, every kid coming out of college will know it, and everybody will know it, but at the moment it's still quite a mind shift for some companies.
So basically, if I'm considering upgrading, or implementing a new, MQ environment, Kubernetes is not a prerequisite. It's not a
prerequisite. No, that's right. You can quite happily use native HA and it could be your in between step on the way to containers. It could be your final step. Your destination might be to do it on VMs, which is also perfectly fine.
So the option is really yours. The folks doing the deployment, that's great. I know our customers appreciate that optionality. Many are just not ready to tackle Kubernetes on an enterprise scale.
So Dom, just a quick question from my side. Since we were talking Kubernetes, I just want to see if there are any specific advantages of using IBM MQ on OpenShift versus the other flavors of Kubernetes.
Sure. So, I mean, if we go back to the, why is OpenShift a good thing? We spent quite a bit of money acquiring Red Hat, so we think it's good. Obviously, we do. So they integrate hundreds of open source pieces into, and just one example is the software required to run these operators, which is why those operators don't necessarily automatically run on other Kubernetes distributions. So that's pre-integrated, the operator lifecycle management and everything else. That's along with, as I say, hundreds of other pieces that they bring to bear on it. And they make, Red Hat OpenShift makes opinionated choices about how to run a Kubernetes environment so that you don't have to. Otherwise, you could spend months, years in analysis paralysis trying to decide the best way to run Kubernetes. They believe they already have the best way to run Kubernetes, and they've already pulled those things together. And so then you can get on with just enjoying the benefits of being in containers, which is really about having a homogeneous operating environment. And if you're using OpenShift in different cloud providers, for example, then it looks the same, whether you're using managed OpenShift on Azure, ARO, or whether you're using OpenShift and hosted by yourself on Amazon or on-premise, they all look the same because they've got those same opinionated capabilities. And so you can move around, you can deploy an MQ network across all of those, and the commands to look after them and to install things are exactly the same. So that's the big benefit of doing it on OpenShift. We can bring you operators to other environments, but of course, then we've got to make sure that the relevant underlying capabilities are there to make the operator run. And so that's why we've got to do a little bit of work. And there are tens of different Kubernetes environments out there. Now, MQ is supported to run on anything that is a CNCF Kubernetes provider. That's fine, but not with the operator. So you have to know a lot more about Kubernetes to actually deploy it in those environments. We'd like to bring the operator to more of those.
Yeah, so it means that if you're running MQ, OpenShift becomes an easy choice and much more flexible from a deployment standpoint without having to rewrite some of those operators. And then you can adopt any Kubernetes, but then you may have some hurdles.
You can hire someone from the market who's got OpenShift skills, and they can immediately use your environment, as opposed to somebody who's got Kubernetes skills and then has to learn your particular opinionated style.
Great. Thanks,
Ken.
So how does NHA affect current users of RDQM? How does that impact sort of folks that are considering the migration?
So I would certainly say that they shouldn't worry. If you're using IDQM, don't look at this and think, oh my goodness, IBM are, totally focused on this, and I should worry about being on IDQM. Certainly don't do that. We've got enough customers on IDQM that we're going to be keeping that going for a long time to come. We've just introduced a new feature to it, actually. One of the other announcements was encryption across regions on RDQM. So we are very selectively adding some new features to RDQM where they're really important to the market, and we expect to be supporting it for many years to come. Have in your mind that native HA is the route that we're going strategically. New features, generally speaking, innovations will be on native HA, but there's a big enough customer base that you don't need to worry if you're sitting on RDQM. And I guess I should sort of peel back even further to customers that are using multi-instance, or they're doing their own HA, or maybe they're not doing HA at all right now and they want to move to using some form of HA. Go straight to native HA. That would be my advice, is go straight to native HA. There's no need to at this stage look at RDQM, but if you are on RDQM, you don't need to worry. So it's providing a similar logical capability. It's providing that sort of quorum-based shared nothing architecture. Yeah, native HA is where we're going to be putting the brand new innovation.
Yeah, of course, since we have many customers using IBM MQ, the context that we've heard RDQM introduced is within the capabilities of MQ IPT, and being able to deploy sort of a proxy in the demilitarized zone for messages either coming from or going out to other business partners.
Sure, and that's still perfectly available with native HA as well. I think all of the things you've done to extend your messaging network, whether that's by going over the public internet or whether it's by putting private connections in, anything like that, it still runs the same. At the end of the day, a native HA queue manager looks like any other queue manager. It's the application doesn't know that it's talking to a native HA, an RDQM, multi-instance, or just a standalone one. It's just a queue manager. It's talking over a standard protocol, whether you've chosen AMQP or MQTT, or whether you're using the JMS interfaces or you're talking to it directly with the client. It's just a queue manager. And then you can connect into that network, and it can be connecting over IPT, that's internet pass-through, to get across public internet into another zone and find the queues over there as well.
Thank you. That's wonderful from our perspective as well, being in your orbit, so to speak. From a queue manager is still a queue manager is still a queue manager. So
yeah.
So last but not least, can I combine? We have a lot of customers that are also using clustering. Obviously, offers a lot of capabilities, to application developers. Especially where brokers are kind of coming online. They may be remote. It could be a B2B type scenario where through acquisitions and other things, you've got new queue managers coming online remote all the time, and some going offline as well. And obviously clustering really helps with that. As far as what you have to define upfront. From an application standpoint, as far as queues and things like that, as you're having a new queue manager join the cluster. But the question is, can I combine NHA and CRR with clustering? And are there any gotchas that we should look out for there?
You absolutely can, and really you should see a native HA queue manager as one node in your overall network, because at the end of the day, it is one queue manager. And even when it moves to another site through cross-region replication, something I didn't mention actually, if you want to do maintenance, for example, and use the cross-region replication to help you do planned maintenance, that is a 0 RPO. So there's no lost messages. You can use it to get to another region, move into that region and things like that as well. So I should have mentioned that. So yes, so think of the nodes in that network that you've got through clustering as being individual queue managers, and those individual queue managers have their own individual resilience. I think I might even have a
Yes.
picture of something like this here. So there we go. So hidden underneath the individual node in the network, you've got this native HA queue manager. And it could be that these native HA queue managers are spread across a hybrid cloud landscape. They all sit in different places and they're being used for networking. And that's something we should probably talk about in another call, the whole concept of the network.
Yes.
But they could also be being used for workload balancing. And this is quite often done where you might say, right, okay, so here in this case, I've got like 5 queue managers effectively, each one of those highly resilient with native HA, but I might say I've got the same queues across all of those,
Yes.
and I'm sharing the queues in a workload balanced style. And you
Yes.
might be using MQ clusters, you might be using uniform clusters to do this as
Yes.
well, which is another form of the cluster which would distribute the applications as well. It's sort of application balancing, whereas the cluster itself is doing the message balancing for you. And so you can have those two things happening at the same time. And that is actually one of the best ways to get really high service availability. So then you can say, right, I might not be able to get to all of the messages because there might be just a few seconds where this queue manager on the left-hand side here is busy swapping to one of its standbys. So just for those few seconds, I've lost access to the messages, but I can always put messages because there's another 4 queue managers here quite happy to take my messages. And so, I've got a cluster workload balancing across the other 4 queue managers. So that gives you maximum, using the cluster in combination with native HA gives you the maximum service availability. And then also when you come to the message availability, well, in this case, you're only losing access for a few seconds to a fifth of the messages. So still the other, what's my proportions here? 80%. The other 80% are still completely available. Yeah.
Well, that is wonderful. Every architect out there likes getting more by combining things.
I should also just say one more thing on that topic. So there's an implication on this slide. If you think of these gray boxes as being like the separate hardware that everything needs to sit on, there's an implication that you need to have that many different pieces of hardware. So that's 3 times 5. So we're at so 15 different pieces of hardware. But of course, you can splice it across. So you could have, say you had, I don't know, 3 native HA queue managers. They could be spread across just 3 nodes. And then you have an active on one node, an active on another node, active on another node. And then if something goes wrong, they go and share with another active when that happens. So it doesn't mean, you don't have to have 15 different boxes here. It could be much more refined than that.
That's great too. Well, thank you. It was really great to have you on. Really great to have this discussion. It's very timely for a lot of our customers. So I very much appreciate this. Before we go, I'll reach out to our moderator on whether or not we have some questions from the audience. I know that we've been asking them to wait to the end.
Yeah, thanks so much, Tom. We did have a couple questions roll in. The first one came in from Mohammed, and I think it was a clarifying question that came in around 11:27. So it's more of a statement. I'm thinking it says native HA or RDQM, which is highly available and easy for DR. So I don't know if you can dial back to what you may have been talking about at that time for that question. If not, I can try to get some more clarification around it.
Might need a little clarification, but I think the first thing that comes to mind is that they both provide really good high availability and disaster recovery. What's different between them has a lot more to do with how you operate them and how easy or difficult they are to maintain over time. And so I think that the easiest end of the scale there is going to be native HA, especially if it's running on containers, especially if it's running in OpenShift. Really gets to the point where you can deploy just based on a descriptor file. RDQM, a lot more work to do to install and get all the right pieces in place to make sure that that all works. Once they're both up and running, they are largely pretty similar in what they're providing from an HA and a DR perspective. So, I mean, there's some, if we want to get down into the real nooks and crannies, we could talk about some subtle differences, but at a logical level, they are essentially providing the same quorum-based 3 sites within a region and then 3 sites within a second region. They're doing the same thing.
All right, perfect. Well, I hope that answered his question. If not, Mohammed, please feel free to reach out to us. Okay, the next question is a two-part question that came in from Gavin. For an organization currently running multi-instance queue managers, what is the clear ROI or technical advantage of migrating to the newer native HA with cross-region replication?
So, yeah, great question. I think the first thing I would say is if you are not enjoying being dependent on shared storage, or if you want to have more portability, so maybe you want to be able to deploy in a same style way in different environments that might be different cloud environments and things like that, then certainly that would be a reason to move. Another thing, of course, with multi-instance is that although multi-instance does work in containers, it does have some downsides. And there are some issues where, because of the nature of the way that multi-instance works, it doesn't work very well with Kubernetes. That's a general statement about shared things that are relying on shared storage locks and things in containers. It doesn't have the quorum mechanism to work out the split brain scenario. So if a node goes down, it makes it quite difficult for Kubernetes to know whether another node can take on that work. So yeah, two really good reasons to go, and I think you'd probably be pleasantly surprised by the shift across to from a licensing perspective. So it does need a different license. I hadn't mentioned that here, but you do need a slight uplift in the license to move to native HA. But at the same time, you don't need the replica license that you had before. So you sort of get an up and you get a down as well. So it might work out back in roughly the same territory. So, and certainly, as I say, if you're moving to a more cloud native style and containers, then it's definitely got a better profile for that.
Okay, great. Thank you. And the second part of his question is what level of refactoring or disruption should we expect?
So, and I guess there's two types of refactoring. So one is that it's going to be a slightly different way of building MQ infrastructure. If you're using things like the operator and things, then a lot of that is handled for you. So there's not a lot of different, well, it's different, but it's easier different because it's moving to a style which is, you can walk up to a blank container environment that knows nothing about MQ, hand it a descriptor file and say, build me a queue manager, and it will just do it, which is nowhere near as, it's much more difficult when you're working in a virtual machine environment to install and set everything up and set up shared storage and everything else. The other question, of course, is what about the applications talking to MQ? How much do they need to change? And I'd say there, very, very little indeed, because essentially a queue manager is a queue manager, as we said earlier. They're still going to be talking, especially through containers, they're going to be talking to a root in OpenShift or an ingress in other Kubernetes capabilities, which is just, essentially is a URL to get to that particular queue manager. So they don't see it as anything different. It should look much the same.
Okay, great. Thank you. The next question comes in from Sev. What are the skills required from our central messaging team?
I would have had to say up until 2 weeks ago, you had to know Kubernetes, right? And that would have been quite a big hurdle. I don't have to say that anymore. So there would be some new ways of, say you didn't choose to go the container route with native HA and you chose to just do it on VMs. Now you haven't got to learn about Kubernetes, but you will have to set up something in terms of how so what's going to restart your queue managers if they fail? You need something outside of MQ to do that. So you might have to use a system daemon or something to do that. You might have to set up something to make sure that you reroute across the different queue managers at the right moment. So there's certain things you're going to have to set up, but they're not massively different to what you do today because you're still running on virtual machines. So and that's all very well documented as well. So it's nothing major there. So I think the hurdles are very low. The barrier is very low. And then if you are moving into containers, that's probably because you've got a direction to do so, and you've probably got teams in the organization that have those skills for you.
Perfect. Thanks so much. And the last question comes in from Tim. Considering the push toward cloud-native architectures, which of the HADR options discussed provides the greatest operational cost reduction and simplification when deploying MQ on managed Kubernetes services like EKS or AKS?
So I'm gonna, I mean, I'm biased, obviously. I'm bound to say native HA is going to give you the best options. It is worth, and I didn't come to this earlier, but when we look at this here, the license you pay for is on this active box here, and on the one you're replicating to in CRR, if you're using CRR. You don't pay for the replicas here and here, and nor do you pay for the replicas in the second region here and here. Now that is different to RDQM. It's also different from multi-instance. So from that point of view alone, there's some potential cost savings as you move into this kind of environment. I think also operationally, as you see more and more customers moving towards container-based deployments and that skill set being ubiquitous, that because the operation is the same, how do I look after, install, scale, secure all of the things that are on Kubernetes, especially in OpenShift, that becomes homogeneous. Whether it's MQ, whether it's App Connect, our integration products, or whether it's somebody else's products that you're installing on there, they all work the same. Most of the layers underneath, most of the operational layers underneath will be the same. And the only thing that's different is the thing that is really specific to the product. So where before, all the scaling and the little bits of adjustment for non-functionals and things was different for every single product, they become homogeneous. And that, again, means you can get skill sets from the market to do a lot of your operational work. You only need to be an MQ-specific person if you're dealing with the functional aspects of MQ. If you're just dealing with deployment and things like that, then just OpenShift or Kubernetes skills will be enough. So there'll be some operational savings in there too. But that does assume, of course, that you bought into containers and that's your strategy across the organization.
Great. Thank you so much, Kim. That's the end of the questions that came in. And Tom, handing this back to you.
Okay. Wonderful answers. So thank you again. Navdeep, would you like to add anything in close?
I think this is super exciting. Improve the stability, resiliency, with HADR, and also the licensing aspect that Kim mentioned towards the end was very insightful as well for customers when they're evaluating different options.